Good morning. I hope you have a nice break on Tuesday, or maybe a busy Tuesday. But now we are going to continue our journey on our descriptive statistics. But before we do it, let me say something about the project, because I think last time we just mentioned, but without uploading that to the Blackboard, you can take a look. On the example that I actually showed you last time. This is a zip file. You can go in to check out. For the project, it will be, as I said, will be due by the end of semester. I put it on December 1st. So it's, I think it's just a few days after you do the final exam. So still have some time before you finish. And then, as I said, maximum team size is 6. You can do it by yourself, or any number will be fine. And I assume that no free riding, the score will be equally divided unless there's some special issue, but usually I don't take care of because you can always submit your own. If there's someone have been free ride, you show evidence, you can exclude him. Usually I don't take care of this kind of complaint. At the end of the day, you just need one member to submit your project. No need to every member do it. But we'll talk about submission issue at the end, but probably just submit a Blackboard. Just one person. And make sure that you write your group members very clearly in that sense. Okay. So I think it's clear. If you have any question, please feel free to ask me. I put it there. I think it's very clear what we do. It's a business report, so it should be short. So I limit 2 pages for every number of group member. So if you do it by yourself, only 1 A4 paper, 2 sides. Okay, you have 2 A4 papers. Okay, you can do appendix, but the main thing is just 1 A4 paper for each group member. So I hope that will be clear. It's not about how many pages of writing, but whether you convey the message. Right? You can take the example of previous years to take a look at what had been done. I didn't say that good or bad, you can decide, but it has to be business professional quality, because this is what we'll be pushing for. Right? Anyway, so let's, if there's no question, then we will continue our journey on the descriptive statistics. But as we do, because we have done that on Monday, so probably it's good to review a little bit quickly what have been done. Okay. So to remind you that the overview of our class is we do descriptive statistics. Basically, we don't create new knowledge. We just extract what has been there. Okay. And we assume data is here already. Okay. We don't talk about the data issue, how you clean the data, all those kind of stuff. You will learn it by yourself, or there are more advanced class to do it. It's not our job to tell you how to do that part. Okay. And to do it graphically, the data also, you have been doing this since your primary school, right? You know how to draw the pie chart, bar chart, histogram, all this in primary school, secondary school. Okay. It's not my job to teach you about those. Of course, they're important, but I think you have learned it too many times for me to cover it in the college level. So I hope that you would know how to do it, but rather we focus on the math aspect, how the formula works. And because in computer, now it's easy, you can click and do whatever calculation you want. You need to know what is behind, what number makes sense, what kind of formula would suit your purpose. Okay, so let's review, right? Descriptive statistics, basically we don't add any new thing. Okay, and for the second half of this class, we will do, or this course, so second half of this course, we're looking at the second thing, we create new knowledge. The idea is like, we want to study, say, the whole Hong Kong, but we're never able to ask everyone in Hong Kong. So we just pick up some people, because sampling, right? We pick up some part of the thing we want to study, and we try to study this small part of the data what we have, and then we try to draw conclusion of the whole picture based on what we observe, only a small part of it. And how large is sample, how your conclusion from the data can extend to the whole big picture is what we talk about. Okay, but we have to start from the very beginning. Consider with data. We want to have a better understanding about the data. Okay, and because now with big data, these days, right, data is collection and storage is very easy. AI, right, has huge number of data. So now actually become more important for the descriptive statistics, right? Imagine you are a big platform like Amazon, Jingdong, Alibaba, more or less they have whole picture, right? They have almost most of consumer in the world joining, right? So basically it's like it's getting increasingly important for know the meaning of how to describe your data. And a quick recap will be there are different type of data, and you have to remind yourself what kind of tools apply to which kind of data set, which type of data, right? I mean, if you apply the wrong one, you will enjoy wrong conclusion, right? By saying, remember when I talk about mean or average, it has to be something add or subtract to be meaningful, which when you have categorical data, is not so meaningful, right? And for continuous, it always makes sense. Sometimes discrete doesn't make too much sense there, right? And sometimes you should be very careful of the type of the tool you're using, okay? As I said, I'm not going to talk about this. It should be in your mind what kind of data should apply which kind of graphical analysis. Now, here is the focus is the three main types of numbers that we want to know if you give a data. And as a business application, this will be the case where you tell your boss, these are the numbers that boss would care, right? Just to remind you why we care about this. The first one is called central tendency. This is the first type of data that's the only number that you would tell your boss what's about the data, right? It's the mean, median, and mode. And I will tell you that, right, the three different numbers would be useful in different type of contexts, right? Depend on the data you're looking at, right? Whether the data is cardinal or ordinal numerical or categorical, then you will see which one would apply. And later you will see the dispersion, the shape would affect whether which one would be more appropriate. Okay, but this three number, mean, median, mode, will be the useful measure that with a single number that represent whole data, right? Because your boss gives you a data set, you want to tell what's going on there. And the measure is always mean, median, mode. That's something they care. And today we talk about the two things called dispersion and shape. And they will be talking about the first one, dispersion, is asking you to say how spread out the data. That's the name dispersion. And that means that it's asking ourselves how accurate our single number in central tendency will be useful. How useful, how important are they? If the data is very concentrated, then your mean, median, mode will be a nice one, right? Very accurate measure. It's how accurate our central tendency is. Right? You know that they call the standard deviation, the variance are the thing, right? So that's basically when you learn finance or what other subject that's about statistics, the two things you would care, the mean and standard deviation, right? There's two numbers that come out of your head and people ask. And now with the financial crisis and all other things, people actually care more about the shape as well, right? The shape is the skewness. And people now these days talk about equality, diversity. This kind of stuff actually concern us about the skewness with the symmetric. Say, for example, people making money, right? We will care about a lot of people. Is a lot of people poor? Or they're the super rich people, right? Because we have super rich people in the data set. Look at the mean will be super high, right? It's not many meaningful, right? Remember the example later we'll see again is when I have an extra high number there, the mean will be much more than the rest of number. Okay, we will learn that again, but symmetric means a lot, right? Because in terms of a marketing application, right, you look at how much you price a product may depend on the average income, right? Or average who has to pay for a product. But the average not be too meaningful if the number is skewed. Right, the skewed, then you would change your strategy, right? If it is skewed to the right-hand side, I mean, maybe you would design some niche product to cater for those people. If skewed to the left, you would do the discount product, right? So that would be the thing we want to look at. And kurtosis, looking at the fat tail, right? Is whether two extreme values are large or small, right? That's useful for measuring financial risk. As I mentioned in the last class, is the failure to acknowledge fat tail will be a lot of problem. And insurance company, they do care about fat tail. And if many of you may be doing accounting or auditing, fat tail will be an important thing to look at as well. So that's why when you look at Excel, later we have time, we will look at that today. If not, next class, we'll look at when you ask Excel to generate summary statistics, they'll generate all these numbers, kurtosis and skewness, and all is accessible in Excel command very quickly. So that's why we cover all this. It's easily available in Excel. Okay, just to remind ourselves what is the mean. I'm not going to talk about this thing, but just focus on the review on the formula. Remember, the mean you learned from the primary school is adding all the observations over the number of observations, right? So you learn this mean, but probably you may not remind yourself what does that mean, right? And to remind you, mean is a measure of central tendency. It's where the center of data is, right? Where the center of data, where the center is. It's a number that you want to represent the whole data, right? And by center, it means a distance. Here means that the sum of the difference from the mean is 0. Just graphically mean this is the easiest to remember, right? Where is the mean is? Mean is the location where you count the data, right? Each data set, data point, look at this sum of mean, right? Left and the right. The left is red, the right blue, okay? It is exact location where some of the red is same as some of the blues, okay? It's exactly the center. So it means that when they talk about adding observation over n, indeed we're talking about the distance, okay? So that's to remind you, for mean to be meaningful, the distance has to be meaningful, right? For distance to be meaningful, you should be talking about applying to numerical data, not categorical, right? So average rating, if your rating is a star is only allowed 1, 2, 3, 4, 5, then it's not meaningful, because 1, 2, 3, 4, 5, 3 to 4, and 4 to 5 is very different. Look at the star hotel rating, right? 3 to 4 and 4 to 5 is different. It's not even, not the same. So talk about the difference doesn't mean a lot, right? So an example shows you that mean is very useful, but we look at the data when you have a outlier, right? When the number changes from 5 to 50, okay? And the mean for the second case doesn't mean a lot, right? Because 12 is far away from the first 4 observations, means that the mean is far away from majority of data set, okay? And there's an issue here, right? But we still use mean, right? So how do we handle this? Of course, you probably don't learn it in the high school, but this is how actually people do in practice. Either you trim the data or you linearize the data, okay? By trimming, it means that we just don't take care of those people, right? When we look about income or people are doing, right? And we ignore those billionaire, extreme wealth people, right? You don't care those people, right? Right? Say you talk about the income of the person, you will probably ignore housewife, right? Housewife probably is not going to make money, right? Right? So they will not generate any income. Of course, they have some function, but in terms of income, they're 0, right? But you have to be very careful, right? Or the kids, right? Kids go to school, right? They don't generate income. So you should exclude them from the data, right? A bunch of 0 when we talk about income. Or linearizing, this also often used is instead of allowing the extreme value, you cut off at that value and replace those extreme value by the cutoffs. Okay, in that case, 50 is replaced by 4. Okay, and these are more advanced. You actually learn that when you go to practice. Okay, and people would want to see the raw mean, the standard mean we see. Also want to see the trimmed mean, and also want to see the winterized mean. Okay, usually you report 3 numbers, and the 3 numbers are close enough, then probably we have confidence about the mean. If the 3 numbers deviate too much, we have to be more careful. We need to look at more numbers. Okay, so that's how you would use these kind of techniques. Another technique we use is called weighted average, right? And as we all know, right, weighted average is the common thing you see is GPA, right? It's the weighted average. As I emphasize, my class is important because we have 4 credits, right? Because of whether you get an A here or A minus here will still affect your GPA compared to the cost of 2 credits, 1 credit, or 3 credits, right? Because multiplied by 4, right? And that is very important. And the other important use case is when you do data using grouped data. For example, you try to collect your marketing, right? You work with marketing manager. You try to collect how people want to spend on a new product. So what you're going to do, maybe you go to Hong Kong Island, do 1 sample, go to the Kowloon and do 1 sample, and go to a new territory, you do 1 sample, right? You may do 2, 3 samples, okay? But in that case, do you want to do average of this? Probably not, right? Because you would imagine that new territory has more people than Kowloon and Hong Kong. So you should average weighted by population, right? Or you can imagine that you are doing a survey in the Greater China, right? You do it in different provinces. And different provinces have different population, right? Naturally, you should weight the data by province population size, right? Because very often you have the data, income data for each province, right? You want to look at that, then you will weight it by the income, right? Weighted by the population of each province. Okay? That is very natural to do things, right? But anyway, they are all rather advanced thing, but I just want to tell you that you will see this when you look at the data, and you should also apply this nicely, okay? And just a final remark before we go to median. A raw average, when the average we have is just a simple weighted mean, but each weight is just 1, right? Each observation the same, right? So that would be something that keep in your mind that the same, that general thing. And the other thing that sometimes you would concern ourselves is not adding things, but rather we do multiplication. You multiply and take roots, okay? And we may ask ourselves when you use arithmetic, when you use geometric, okay? You'll be pretty advanced to tell you what to do. But if you learn finance, you learn about interest rate, right? You talk about the return over the number of years, right? Usually we use geometric mean because we assume your investment will be reinvest, right? And in that case, your money goes in again. In that case, geometric mean would make more sense, right? But I'm not going to go to detail, but I just show you there's a possibility that you should not confine yourself to arithmetic mean. There are many mean you can look at. Same as geometric mean, right? It's very often in finance application, you want to calculate average PE of different company. And in that case, you're using the harmonic mean, which has come from that. But I'm not going to go into detail because they're all technical. I mean, you will face them in the future, but I just want to show you here, just to remind you for those who are not in the first class here, is all the grade box are technical. It's not required. I just cover it because I think it's important for you to know. And if for prepare the exam or prepare the assignment or project, is sufficient for you to know the purple one. And the purple one is theory. I don't expect you to recall them because open book anyway. So what are you to do is operationalize the operation, like the example in the green box. The green box is something that you should know, right? And the knowledge behind the green box are the purple box. Okay, so you should know very well how the green box works. If you don't know the green box, then I'm sorry, then probably you will fail, right? So I'm going to not to talk about this example. This example we talk about simple return and compound return. It's try to explain why you want to use your metric over the arithmetic, but because of time constraint, I think we're a little bit fall behind the schedule, so I skip it. If you study investment, this will be the first example they would look at, why you need compound interest, okay? But I'm not going to talk about those, okay? If you have time, you can go back, but just we can skip. Now that being said, we have mean, and the problem of mean is the outlier, right? So one natural question is, okay, we don't want to deal with trim mean or winterized mean or weighted average, whatever, we don't want to do it. Why don't we just focus on even more simpler way? It's called exactly the center, the median, right? Median is like you saw the data from the smallest to the biggest, exactly the middle guy, right? If we look at the exact middle guy, then we're done, right? No matter how big the biggest guy is changing, no matter how small guy is doing, doesn't really affect because exactly the middle guy, right? And how do we care the middle guy? So that's why you see the middle guy, but the math is rather crazy, right? Why we have to do a crazy thing? Because of the middle is not clear. It depends on the number of data, okay? Consider the case, we have 3 numbers, 1, 2, 3, okay? The middle is very clear. We have 3 numbers. The middle is the second guy, right? If you have 5 data points, the middle guy is the third guy. There's no doubt middle, where's the middle, right? Middle means they have same number of observations on the left and the right, right? You have 7 observations, then the middle guy will be the 4th guy, right? 3 on the left, 3 on the right, no problem. So that's why we have the first bullet point. The solid data is n plus 1 over 2, right? We have 3, it's number 2, it's n plus 1 over 2, right? Because 3 plus 1 is 4, 4 over 2 is 2, the second guy, right? If you have 5, 5 plus 1 is 6, 6 over 2 is 3, right? So this formula is fine. When odd, when even, where's middle? Suppose you have 2 data points, 1 and 2, where's the middle? I don't know, who knows, right? It should be somewhere between 1 and 2, right? So how do we do about that? The usual way to do it, as in many software package, is do the average of these 2, right? So that's why even median is more fundamental. We talk about average first because median be on average, right? It's average of the 2 middle guy, right? In the case of 2 observation, it's just average. In the case of 4 observation, the middle guy is the second, the third guy, average of them. Okay, so that's why the formula is like this crazy number, right? N is 4, right? If n is 4 observations, it's the second, the third guy. So that's why half of the second, half of the third, right? So that's the formula, right? So the formula looks like 2 separate sentences. When it's even, it's odd, right? So this is the formula, okay? But we want a one formula that helps us to get this answer. We'll use the floor function and the ceiling function, okay? And how does that work, okay? If this is odd plus 1 is even. Even over 2 is still a number, integer, right? And this integer. For integer, this floor function and the ceiling function has no meaning because integer remains integer, right? So that is the same as exactly the first bullet point, right? So that means that this, when integer, same as this guy, no problem, all right? And which is even, even plus 1 is odd, all over 2, it's become not a integer decimal number, right? And we just need to get this floor function, means we take out the decimal number, just get the integer, right? And we get this this ceiling function, we get the decimal go by 1. So just go by 1. So exactly this formula. Okay. Why I need this one? Because this is how you write your program if you have to write your program. Okay. Just give you an idea that how this is being defined in computer. Of course, you don't need to remember this formula because this is come from here. This is the abstract way, or you would want to write program, this is the way you write. Okay. Instead of writing it, of course, those people who know computer, you say, oh, okay, why in this? Why don't I write conditional statement and write this? This is much slower. This is floor function is much faster. So this is the way you should write. You should ever write a program. But anyway, I'll just let you know what are they. Okay. So as I said, the implication is exactly the middle point, right? And the good thing is it doesn't change, right? Unless the middle data point changes, right? So it doesn't really matter any data other than the middle changes, right? It's still the same. So the median is pretty robust to your data error, right? No matter how data error doesn't change a lot, or you come up with new data set, update your data very often, right? The data comes in online dynamically, right? Keep coming up. The median doesn't change much. The mean can change, right? Suppose you consider you're looking at the income data, right? You ask X number of people, average is this number. Suddenly, you reach a very rich guy, ask him, your number jumps. And suddenly ask a very poor people, the number jump again, right? But the median doesn't change, right? So it's very important when we talk about big data, right? When your big data, your data comes in very quickly, right? You want something stable, median would be a good one, all right? Anyway, as I said, green is most important. Let's operationalize this one, right? Probably everyone will know it from your high school, right? So for data 1, 2, 3, median will be just, remember the middle guy, we're 3, the middle guy exactly second guy, right? Because m plus 1 or 2, right? 3 plus 1 is 4, 4 over 2 is 2, second guy, 2, right? When we have n is even, they have to be careful, right? Because 4 plus 1 is 5, 5 over 2 is 2.5. 2.5 means that you looking at the average of the second guy and the third guy, 2.5. So it's half of 2, half of 3, 2.5. Okay. Now when you have outlier, 4 becomes 40, okay? Doesn't change, okay? So it means that it's robust to outlier, robust to data error, okay? So that's why the median has a very nice property. So that's why it's nice to always have median. Remember, when we calculate median, we don't need to add and subtract, except looking at the average, okay? Of course, one thing that we didn't say it out here is, if these two numbers, the middle guy, are very big difference, right? Then probably should report these two guys instead of a single number, right? Probably the better way to say, right? If this is, suppose it's 1, 2, 30, and 40, okay? Then you probably should report the median is 2 and 30 instead of actually doing the average, right? And when your mean, because average, right? It means that this average should have making sense, right? If your data is not numerical data, right? The median you probably might want to report may not be just number, because average doesn't mean a lot. When the number you cannot add and subtract, you should report the middle two guy instead of actually doing the average. Okay, that's two and caveats. I mean, when you do apply, but is that okay for the median? I mean, I hope it's clear. I mean, everything follows naturally from the definition, and you have to understand what is behind statistics, because we what we taught is not very complicated. The main thing is talk about understand why we do this and what the rationale behind and how to use it, right? Because open book, right? And data, the information is available everywhere, right? You have AI, right? You need to know what are they, right? I mean, the calculation or the formula, you can easily click and it's done, right? And why you're better than the computer is you know when to use what. I mean, of course, sooner or later, maybe hundreds later, this will become obsolete, right? But before we do that, that is our comparative advantage, right? If you have no problem for the median, let's go to the mode, okay? Mode is the most easiest one, right? You just go to the frequency table and look at the one appear most often, right? Count the number. The one appear most is the one we have, right? So mode is looking at the maximum number that appear in the frequency, okay? And the only one thing controversial is a very rare case where everything only appear once, okay? And in some textbook, they will call this mode doesn't exist, okay? But I think we will follow the tradition in some software, and then even if everything appear once, we'll call everything is mode. So if the data 1, 2, 3, then mode is 1, 2, 3, okay? Just to make it there. But do note that most frequent value can be more than one, right? Suppose the data 1, 1, 2, 2, 3, 1 and 2 are both modes. Okay. Now in this case, do note that this my first bullet point is different from some of the textbooks. Some textbook would do as I do. If everything appear once, then everything's mode. But some textbooks say there's no mode. So just make sure that you get what I'm doing. If there 1, 1, 2, 1, 2, 2, 3, 3, 4, then 2 and 3 appear twice, then it's 2 and 3. If 2 appear more, then mode is 2. Okay. So mode, you can see involve no calculation besides counting. So that means that it applies to any type of data, even though the number, right? You can ask data like how people go to school, maybe by bus, by car, by walk, right? By train, right? These are not numbers, but you can easily do it, right? It's using the mode, right? And median doesn't make sense in that context, and average doesn't make sense. Of course, you can transform the problem, say how much they spend on the transport, and the number you can do average, you can do median, right? But if categorical, this is the only thing you can do. You have to do mode, right? Okay. Is that okay? Now I hope I convince you that learning the mean median mode is the single most important thing when we talk about data. All right. So now we come to the second part, is the caveat, right? Is how accurate are this mean and median and mode, right? Of course, from now on, we are doing about calculation, so we are focusing on numerical data, right? Because looking about how spread the data is, because spread have to measure the difference, have to be difference makes sense, right? When we talk about the dispersion for categorical data, doesn't mean a lot, especially say what the dispersion about how to go to school. I mean, it's hard to say anything, okay? Of course, there's some measure, but it's out of the scope, okay? There are 5 different standard measures when we talk about the data dispersion, okay? Basically, although there's a 5, actually only the 2 types, okay? The first one is called range interquartile range. It's talking at, maybe give you the formula first. Range, the idea is looking at the biggest and smallest, the distance, okay? In the quartile range, also distance, okay? But instead of the biggest and smallest, what we do is imagine the data are from smallest to biggest, okay? We know one thing is median will cut this data into two halves, okay? And the two halves, you can calculate the median for the two halves. The distance between these two median is the IQR, okay? And there is a lot of subtleties on IQR, depend on how you cut the middle, how you cut things, and this IQR is not really well defined. Okay, range, there's only one formula. IQR, if you look at software package, at least 9 different definitions. In Excel, at least 2 different definitions. We'll teach you one of them. Okay, there's many ways to define. Okay, you can look at Wikipedia to tell you, I think at least 6 or 7, but I mean, so that's why I will teach you one, and the one we use is consistent with the it's Excel. Okay, and I think depends on where you come from. High school will teach you one way to do IQR, and in US teach you a different way. In Europe teach you a different way. I mean, everywhere IQR you go to around the world will be very different. But Excel is the same. Okay? Later you will see what we're doing. And the second type of the data, a second type of measure, is called variance SD and CV. They are the measure that depends on mean. Okay. How do you measure this expression? Variance is taking a look. We look at the data set, okay, or the observation. We count the mean, okay, and look at each observation, the distance between each observation and the means. Okay, and for the variance, it's a square distance. Square it and sum up all the square distance, okay, and count average of the square distance. Okay, it's called the variance. We will define formally later. Don't worry, just give you an idea. It's the distance from the mean. Okay, if the distance from the mean is a lot, then it's very spread out. Right? The distance from the mean is very little, then it's very condensed. Okay. And the SD is very simple. Just take a square root from the variance. That's very normal. And the CV is very simple. It's just SD over the mean. We'll tell you why we do that, but basically just one measure here. Okay, but different way of treating those. Okay. Okay, let's go ahead. Range, by definition, is very simple. The biggest and smallest. All right. We often talk about this, I mean, maybe way back 10 years ago, occupying Wall Street or income inequality. We talk about the 99% versus 1%, right? 1% of people making so much money, right? Compared to 99%, right? The idea is the range, right? Smallest and the largest. Okay? Of course, if their sort is xn minus x1, right? And again, the problem, same as mean, is affected by outlier, right? Because we only use the 2 numbers, the biggest and smallest, right? If they changes, then they change, right? So just example, how to operationalize this. 1, 2, 3, 4, 5. Then the range will be 5 minus 1, biggest minus smallest. Right? The biggest is 5, the smallest 1, 4. If 1, 2, 3, 4, 5, 50, the biggest is 50, the smallest 1. So 50 minus 1, 49, right? So is that clear? And you can see by changing this number, things change a lot. So that's why range is not ideal. Okay, range is something is useful, but it's not the only thing we look at. So that's why we look at the second one is called the IQR, interquartile range. For interquartile range, we need to understand what's quartiles. Right? For quartile, now we start with English. Quart means 4, quarter, quadrilateral. Quart is the prefix for 4, right? Tiles is the thing on the floor, right? A tiles, okay? The square, 4 squares. Okay. So that means that we divided data into 4 parts, 4 squares. Okay. And how do we 4 part, right? Look at the second quartile. Okay, let me draw a picture. It's easier to, maybe easy. Okay, you have the data here. Imagine the data. Okay. I draw a box here to present some data point here, right? Maybe this data point here. Okay. And data, this is the range, right? We learn, right? This is the range. Okay. And we learn the median as well. Median will be here. Okay. And median we will define as Q2. Okay. Median is Q2. That's median. Nothing deep here. We learn it how to calculate median. Okay. And what about this is from smallest to the largest, right? So median the first part will be about Q1. Okay. And median on the second part is called Q3. Okay. And this part we'll define as IQR. Okay. And that is Q2 is middle, right? It's M plus 1 over 2. Right? We know the middle, right? M plus 1 over 2. And Q1 is M plus 1 over 4, it's quarter, right? So it's cut into 4 equal part, right? Math problem, you divide it into 4 different parts, you need 3 cuts, right? So Q3 will be 3/3 of M plus 1 data, okay? In principle, that's no problem. As I said, this is always median, Q2. But how to define Q1 and Q3? There's some issue there. We'll talk about it. It's a minor technical issue here, okay? That's why when you talk about quartiles, you have to be very careful. What quartile talking about? Okay, is that clear what we're doing? Is that okay? I clean up my drawing. Okay, IQR is depend on that. Okay, and this is a graphical drawing. This is the middle Q2. The IQR is a difference of this. This is the whole range. Okay, and sometimes look at the software. They call this Q0, and sometimes they call Q4. Okay, this is how Excel do it. If you have a quartile function, you call Q0 and Q5 actually is the mean and the max. Okay, but this is the key font is Q1 and Q3, the distance. Okay, Q2 is median. Just to remind yourself. Now, as I said, there are many ways. Okay, and I will tell you that in some education system they will use the method 1. In some education, method 2. But in Excel, we use method 3. Okay, and this is you learn in some of your high school. And method 3 is very complicated in formula, but the idea is very simple. Okay, but let me show you how you would do the first 2, and then you see the 3, because first 2 is something you also learn in high school. I don't know which book you're using, but it really depends on the syllabus. Okay, I tell you the first 2, and then you learn. Then you let me know. I will learn the 3. So 1 and 2 is very simple. I think you learned it in high school. Is you all the data. Find the median first. Okay, if the median, okay, is your data has even number observation. The median is not observation, right? Median is somewhere in the middle, right? And these 2 methods will be same. Why? Because the median is not the data, so naturally the 2 halves of data, right? They calculate the median again, take a difference, are done, right? But the problem is when you have odd number of data set, right? The median is the observation. The problem is whether you count this middle guy belong to 2 halves. If you belong to, then method 1 If it doesn't, it belongs to method 2. Let me show you the example. It's not something complicated. I think you learned it in your high school, but let's show you this. So example 1, you have odd number of observations, okay? And the coming up will be even numbers, okay? So let's see how method 2 are different, okay? Now, when you have 1, 2, 3, 4, 5, the median is 3, right, naturally. And method 1 will tell you the first half is 1, 2, 3. But method 2 will only forget about 3, just 1 and 2. Whether you include this 3 will make a difference, right? And if 1, 2, 3, the median is 2, but the 1, 2, the median is 1.5, right? And if the method 1, the median is 4, and 4, 5, median is 4.5. So this IQ are different, right? As for if you look at this case, right? If you have even number observation, the median 3.5, right? So the first half was 1, 2, 3, no matter which method you're using, the same. So if I remember correctly, this method 1 is used in the British system, if I remember. Is it the case? Right? But I think method 2 is used in US system. So I don't know European which one they use, because that I said at least 9 different methods. So the one we're going to use is not to rely on whether include or not. We'll use a more complicated way. Sometimes we'll call linear interpolation. And how do we do that? I mean, I show it to you because you need to understand what Excel gives you, right? So what is actually doing? Okay. So what we're doing is something looks like super crazy here. Okay. This function. Oh, sorry, I should have a break, but let me finish this. Give you a break. I'll give you a 15-minute break, so don't worry about the break. So the idea is start from here. Remember, quartile is 1/4 of n plus 1, right? And 3/4 of n plus 1. We'll just use this definition directly. Okay? How do we do that? Okay. What we're going to do is look at your data set, n plus 1. Okay? Suppose we calculate Q1. Q1 is a quarter of n plus 1, right? So P is 0.5, is 1/4, a quarter 0.5. Okay? So what you do is you look at the integers. It's a floor function. Look at the data there. Okay? And say, suppose this is 4.5, say. Okay? Then you look at the 4th data point plus 0.5, which is alpha, which is the remaining, the decimal plot, times the 4th and the 5th data point. Okay? So if you calculate the number is 4.5, you will be half of 4 and half of 5, like the median. If your data is 4.25, then you will be 4 plus 25% of 4, 75% of 5. Okay, because in the middle, right? If your data is 4.75, will be 0.7 of the 4th, 0.25 of the 5th, right? Because where you locate. Okay. So probably this look crazy, okay? But let me operationalize this, and you will find it easy. Okay. I'm not going to give, for those who know the math, this is actually what I'm doing. The standard linear interpolation. If you learn M1 or M2, you will know this is nothing but you divide the line where in the middle. And I use the similar triangle to prove it. But I'm not going to do any math on that. So let's operationalize this. Actually, it's not very complicated. So look at this example. We have 5 data points here. Okay. So 5 plus 1 is 6. Right? And then Q1 is a quarter of that. It's 1.5. Okay. 1.5, I'll take integer 1, is the k, and the remaining part is 0.5. So 1.5 means I'll take the first data point, x1, and 0.5, so the middle, the midway, so means half of 1 and half of distance between 1 and 2. So that will give us the Q1, 1.5. Okay? And for Q3, it's a quarter, say three quarter of the 6, okay? Which gives us 4.5. Okay? 4.5 means halfway between 4 and 5. So you all do is you get 4 halfway between 4.5. So this is the calculation, the difference. Yes. For Q1 here, how do you calculate? The formula we apply will be 6n is 6, 6 plus 1 is 7, 7 over 4, 1.75. 1.75 means that is you take 1 and 0.75, right? So it's you take x1 and 0.75 of this distance, right? Because it will be not in the middle, right? But it's more closer to x2. So you take 0.75 of the distance, right? Because this number is larger, it should be closer to x2 than x1, right? That's called linear interpolation if you want to, you care about the term, okay? And if Q3 will be first 3/4 of 7, which is 5.25, right? So you take 5 and remain quarter there. So you take x5 and a quarter of distance, right? So this gives you 5.75. So this is 3.5. Again, why I do this is Excel to export this one. Otherwise, I will make my life easier to do method 1, right? But Excel they give you is method 3. So I have to teach you this because our course is based on Excel. So if I skip that, it's not responsible, right? When you try to look at the data of the IQR from Excel, you don't know how to calculate, okay? Then I tell you how you can calculate this operationally, right? Is that clear, the IQR? Okay, I'm pretty sure that some of you may not understand. So as a break of 15 minutes, in the meantime, walk around. You can ask me questions. I'll open the reply so that you can tell me how well you're doing today. Have a break of 15 minutes. We come back at 11:35, 38. We have 15 minutes. But I had the reply on so feel free to scan and tell me how we're doing. In the meantime, walk around. Feel free to ask me a question if you're confused. We'll resume at 12:38. 11:38, sorry.
I not know class yet, but slides.
If you have any question, you can just ask TA.
I do have one question. Do you have background in program Python?
No. He just Excel.
Oh, awesome. Is it like
He just Excel, no Python. I mean, I have the data plan, which you can learn by yourself.
Yeah, that was free.
Yeah, please, you're free for me. So it's free until I think March. So it's free for you. I mean, you can use it. I mean, you can learn Python, AI, whatever is there.
Thank you, Professor. I appreciate it.
Yeah, good. One task.
Green is something operationalized what to show you how the workflow thing works. And green is something you should know how to do. If you don't know, you like No, this green thing is like how you apply those formulas, right? I'm not asking you to remember the formula. How to use the formula. So that is the thing that I would expect you to know. I mean, that's something I focus on. I said the quizzes. Complicated, right? And then you need to remember it. I don't expect you, but you have to understand why we do this. That will be useful for yourself. Grade also no, it's never. It's always skewed. Of course, you show me some steps and hopefully we complete our exam, right? But otherwise, you look at the final answer. So you give me something. Right, then you get to pass the credit if you show something otherwise. Both tests are marked by you only have assignment and assignment, and they will be marked by anyone of these anyway. No discrimination, that's fair. What's more, and he is very efficient. Okay.
I'm Matthew. Williams, I'm listening to Sorry, just. Yes. I thought you meant like an assignment right now. It's like, oh my god, I didn't complete it. No, I know Oh yeah. Thank you. You can say so. So it is the introductory course. So like basically we learn some.
I'm scared.
But I think the teacher is really nice. The example is no, I forgot it's around 20%, and also the class participation, and you have some homework. So homework participation. Yeah. So basically, then when let's just say anything. Oh yeah. You guys have background? No. I'm really cool. You don't even use know how to use it, but I'm not. I just know if you study very much, but you. Which is revised. Also, make he will professor you just say revise. Well, like, but the US we have two sessions. That revision to me is like
I saw some of you attend I know who's there. Maybe one or 2 months, otherwise. It's just for me to see how we're doing this dependency. You are tasked with everything. One is to relay those Method 3 is one example.
Based on difficulty.
That is really much easier. There's no methods. I would say there's no methods. Just something using we explain the background. Use some but that was
What should we say is the most important?
I mean, the thing is, like, understand is not successful. It's more.
有啊，有個睇緊啊，我睇緊。
You understand the concept.
係唔使聲。
At least so far. Of course, the future is how. That's one. Some other section. Of course, different person base. But I would prefer you because to learn how to apply.
Yeah.
Well,
13 is
usually my historical things. Usually
one thing I clarify is because why? We cover 3 ways to calculate IQR, and some of you ask which one I should use. I would say use method 3 in exam or in your project, in assignment. The reason is being that our class is based on Excel, so everything we try to follow Excel. As I said, Excel have 2 formula and already. So, but I tell you the one that I think is the easiest already. The other one is even more difficult to comprehend. Okay, so I use the one that's easier in Excel. Okay. And one question that raised in the break is also, I think, worth to talk about is the most difficult part in this class is not math, rather the conceptual idea, why use this and how to use this is the more important. And that's what you remember, right? After 4-year college, what you can remember is very limited, right? But human mind is good at memorize abstract things. So you get the idea, you learn it, then you not easy to forget. And you can pick up very easily, right? Because I'm pretty sure that no one will remember after the summer break. Then maybe you still remember something called mean, variance, SD, hypothesis testing, some key point. But if you remember the story, remember why they're true, then you can easily pick it up again, okay? But before we go, then let's see what we have. Thank you, we're generous. I never have this comment. So far, so good. So it's a class participation, not class attendance. So, I mean, I'm not going to take attendance for this class. But by right, I have to see who is missing. So if you miss too many times, then I have to report to the school. That is same for every other classes. But I don't want to take attendance because that would not serve the purpose. Okay. But if you know your classmate who is missing for too many tell me, then we just try to help him or her out. I mean, but I don't want to take attendance. And probably you ask, attendance required, but how you calculate participation? And usually because I assume everyone would attend, right? So I mean, which means that if you talk to me during the break or I saw your response, then probably you get most of the credit, right? And there's very little differentiation for this part. Okay. And okay. Nope. Yeah, I mean, try to help you. Pre means you want to get a B or above, right? So getting a B would require some minimal effort, right? As long as you do the homework, then or the project, then B will be almost guaranteed, right? And then B plus, and then you work a little bit harder, and A minus, and even harder. But otherwise, I think to bump up more than B would not be that difficult. I mean, for my class, I mean, I can't say for other one, right? So difficult. Yes, I think there's a little bit difficult for this guy, right? Maybe I go a little bit again once more to make sure everyone got it. I think I give 15 minutes break, right? If I do, it's a 15, right? Difficult, hungry, and tired. Okay, so I'm hungry, so tired. What's alpha? Okay, let me clarify that. So the formula here, alpha is a decimum part, integer part decimum part, right? So because I want m plus 1/4 data point, right? So if integer, I don't have any issue there. But if I have non-integer, k will be the integer part, alpha will be the remaining integer part, remaining decimum part, right? So suppose p times n plus 1 is 4.5. 4 is a k. 0.5 is the alpha. Okay. Why this formula works is I want number 4.5 data, which doesn't exist. How can we calculate 4.5 data? Is the fourth data and the fifth one, right? 0.5 in the middle. So that's 0.4. The fourth data and the distance between 4 and 5, I take half of that, the midway, right? If this p times n plus 1 is, say, 4.8, say suppose, right? 4.8. Then what you do is the fourth one, then will be 0.8 of distance between 4 and 5. Okay, so that's how this formula works. It's an interpolation, linear interpolation. Just want to draw a line there, just go in the middle, right? So let me show you again the example that will make sure that you get it. Okay, in this case, n is 5. Okay, n plus 1 is 6. Okay, the median will be half of that, right? So Q2 is 6/2 is 3, right? So that's why Q2 will be 3. What about Q1? Q1 will be 6 plus 1, sorry, 5 plus 1 is 6. 6/4 is what? 1.5, right? 1.5 is the midway between 1 and 2. So you take the first one, halfway between 1 and 2, right? So that's why it's 1.5 between 1 and 2, the midway. So that's why you get 1.5. For Q3 is 3/4 of 6, right? Because n is 5, 5 plus 1 is 6, right? And we want the 3/4 is, remember, you cut it in the 4 parts, right? The last cut is 3/4 of n plus 1. So it's 0.75 times 6, okay? Which is 4.5. And 4.5, yes.
This one is just the first one.
Yeah, because we order them from x1 to xn, okay? So 4.5, you take the 4, and you take the 0.5. So it's x4 plus 0.5 between 4 and 5, right? Because it's 0.5, right? You take the halfway. Okay, so that's how you get Q3. So let me look at this 1, 2, 3, 4, 5, 6. Okay, and Q1 is what? 6, n is 6. 6 plus 1, 7. 7 times divided by 4 is 1.75. I want the 1.751 data. How do you do that? X1 is take the first observation x1, which is 1, right? 1.75. So it's 75% of the distance between 1 and 2. So it's 0.75 times the distance between 1 and 2. Okay? And Q3 will be 0.75 of 7 is 5.75, 5.25. So 5.25, you will take 5 and 0.25 is x5, the fifth observation, and a quarter of the distance between 5 and 6. Okay, is that clear?
Last number, right?
The fifth data is 5. Okay. Now I think still puzzle. Let me get an example. I think this. Let's see. That's why I whiteboard. Okay. Let me see if I can write something. Okay. Maybe not. Maybe do Excel is easier, right? Since we do Excel, let's not use this. Let's open an Excel. Since I want to show it Excel. Okay. Now let's consider the case we have several data points. Let's do an exercise. Okay. We have x1, x2, x3, x4, x5, x6, x7. Suppose there are 7 data. Okay. And let me randomly put some number there to show you how we do it. Maybe I have 1, 3, 5, 7, 9, 10, 15, say. Okay. In that case, how can you calculate this? Okay. And by 7, okay, by 7, which means the following calculation. N is 7, right? N plus 1 is what? 8. Okay. So we want a quarter Q1 is a quarter of 7. So quarter 8, right? Quarter of 8. So in terms of notation is our K, right? For Q1, the K is what? 8 over 4, which is 2 seconds, right? K is 2. And alpha is nothing, right? Because exactly alpha is nothing. So we only need a second observation, right? So Q1, how do I write that down? Maybe actually Q1 is actually the x2, which is 3. Okay. I don't know how to write that down. First quartile. Okay, K1. For Q2, what is K? K will be 8 times 3 over 4, okay, which is 6. Okay. And that's why for Q3. Okay. So that means 10. IQR will be 7. Okay. Now we make the case a little bit more trickier. I'll give one more example. Maybe we give x8, which is like 20. Okay. I just randomly put a number there. Okay. In that case, what's n? N is 8. Right? And n plus 1 is 9. Okay. And now 9 over 4 is what? So R6L was 9 over 4. 2.25. Okay. So which means that the K is 2. Alpha is 0.25. Okay. So what we want is x2, okay, which is 3, right? The formula will be 3 times 0.25, and that will be between it's 2.25, so it's 5 minus 3. So this is the formula. Is that clear? So because we want 2.25 data point, which means that yes.
It's 1 of 3.
Yeah, x1 is 1.
Plus 0.
Q1, sorry, Q1 is looking at the the data that is exactly located the second and 2.25. Okay, which we need this number. We need x 2.25. Okay, but this number doesn't exist. How can we generate this? Will be x2 plus 0.25 x3 minus x2. So this is the formula.
It's just 2, then
Plus the decimum, the distance between the next one. Yeah, x2 and x3. You have 2.25, right? So you wanted 2 plus a quarter of 2 and 3.
it's just x2. Oh, x2.
If just x2, if x2 is just x2, that's 0. Okay? So that's how you get this number. Okay? And for Q3, you have to take times 3, right? A quarter of that. So it's 0.75. Okay? So this alpha is 0.75. Okay? So what we're going to do is the formula will be take this because I want 6.75 data, right? So it's x 6.75. So it will be x 6.75 x7 minus x6. Okay, so it will be the sixth one is 10 plus 0.75 times 15, which is the 7th, minus the 6th. That is what we call the linear interpolation, right? Because how do you calculate 6.75? 6.75 between the two. Okay. I hope this is clear. Otherwise, you don't understand what Excel gives you. Okay.
X6, X whatever is always
Q3 is always with 3/4 of n plus 1. The formula. Right? Because that's what I mean by n plus. The definition. Yeah. You always. Right? This is what? This is 3 plus 5, n plus 1. This is sorry. This number, this guy. Right? This number is always 1/4 of n plus 1. Right? You get an integer here, that common here, and this the distance between the next one. Okay, this is how you operationalize this one. Of course, the formula is complicated, but this is what it is. You look at all the menu, this is the formula to give you. So I try to make you a little bit challenging a little bit here.
It's not like regression. It's not like results.
Not a regression, just a linear, just standard thing. If you learn the M1 or M2, this is standard thing. You have a 2 point and you found a division, right? Okay. I hope that is not that too crazy, But don't worry, you do assignment. Assignment, you include this, you calculate. Okay. It's always difficult when you look at how people do it, but when you actually work on this, you crunch a little bit, then you know. I mean, math is not doing by just sitting and learn. You have to actually work on the problem once, and you're done. Okay. Go home. If you don't still worry about it, block the slides. Do it by yourself. You can do it. Then you know. If you don't know, then you don't know. Right? And the good thing is go to the TA if you have questions and ask him. He's happy to help you on that. Of course, you can ask me next class again, but I hope you know how to do it. Okay. Now, one thing that I want to say is the box plot. Okay. Box plot will be very useful to what we call the 5-number summary, because it tells you the box plot is in this way. The 2 lines there, the 2 lines represent the mean and the max. Okay. The box, there's a box here. The center is the median. It's Q1 and Q2. And by drawing a different example, you can see how they're spread. What's the use case? You want to show maybe the red one may be a store in Hong Kong. The blue one may be store sales results in Singapore, and you want to compare the variance, how they look like, and maybe manager 1, manager 2, right? Maybe this kind of product 1, product 2, those kind of problem. You want to compare the data. Look at how spread they are, where they're located. So where usually we call the 5-number summary is the mean, max, Q1, Q2, and Q3. That's thing we care. Okay. Now, as promised, we'll talk at the variance. I think you learned in the high school already, but just start from the beginning, what it is. Look at the formula. Looks again a little bit difficult, and someone start not to understand. Oh, sorry, I stopped. I should look at the rule reply. I should stop, right? Sorry, I should go back to here. Sorry. I suddenly sidetrack myself. Okay. So 1% of person think it's Monday, 1% Tuesday, 92% is Wednesday, and 3% people think it's Friday. Why Friday? Because we might have typhoon. So these people live in the future already. So I hope their dream come true, but doesn't affect us anyway. Yeah, the IQR Excel method 3. If I will show the Excel after we finish everything here. But if you want, you can jump ahead by yourself and see how Excel calculate this. Okay. IQR. Yep. Median or average or middle, guys. Yeah. Yeah, it's linear interpolation. That's a very good summary. That's a very good one. Yeah, as I said, there are at least 9 different ways to do it. Okay. I tell you only the way that Excel is being used. Okay. That's a good. This means that this respondent actually know everything. So there's no key point. That's very good. I hope you don't feel very bored by my class. Yeah. Okay, so far it's okay. So by telling me honestly, then I can adjust my speed, right? Because there's no rush, right? If we slow down, you learn more, it's more important. Okay. What kind of forever? How is it related? Anyway. Oh, sorry for you. But if they joke, then maybe it's not a joke. Maybe it's okay. Okay, what's yes? Not a joke, but I'm sleepy. Oh, sorry for that. What is WYS? Huh? Okay. Today no mood. Okay. Oh, sorry for you guys. Let's go back. So this variance is the commonly most used measure because IQR and the range doesn't use up all the data point. Okay, so variance is to try to use every single data point to calculate the dispersion, and we focus on the dispersion, the mean. Why? Because we use the mean most often. Okay, of course you can replace this by median, also fine, but this is something we care the most. Okay, so by variance, the definition is very simple. The word is looking at this is the distance for each data from the mean, right? And you square it. Okay. Some of you ask why we square that thing. We square that thing. That means that we don't need to worry about negative and positive. And there are many nice properties to taking square. Become smooth. If you learn M1 or M2, you take absolute value, then become a king. It's not differentiable. That's a lot easier. But in terms of recent AI development, you have that they call absolute deviation. It's used for linear regression, also all those kind of stuff. But I'm not going to focus on those. But traditionally, we focus on the square distance. Okay. When you run regression, also there's many nice properties about square. Why? Because square means what? It's a convex function, which means that the further away you get square more, right? So if there's an outlier, the variance will be huge. So that actually is a good application because the further away, a lot of outlier, the variance will increase substantially, right? Because square, right? So, and it's over n, average, right? So that's why it's average distance, average square distance from the mean. So that's the definition of the variance. Okay, this is a verbal thing, right? Because look at the distance, you square it, add it all up, and divide by n is the average distance, the mean of the square distance, right? And for variance, there are two different types of measure. Okay, the one I give you here is called the population version, and that is the original definition. Okay, and you'll notice some of you may actually learn in high school instead of n is n-1. And why is the case? Okay, this is called the sample, and this part is not explained until we go to topic 5. Topic 5 will give the idea y over n-1. The reason being that I give you the idea first, we'll give you the reason why. The idea is if we describe data you have, that is the right measure. But if we are looking at sampling, we want to look at the whole picture, but we only get a small part of it, right? And then we want to use this variance of the sample to guess what happened in the whole picture. Then we're underestimating. We underestimate. So that's why we divided by n-1, we inflate again, because n-1 are smaller. Let me repeat the statement, but which will be justified when we go to the second half of the class, is if we want to estimate the variance of income in Hong Kong, for example, but Hong Kong has 6 million people, we only say get 1,000 people, say, for example. We calculate variance of 1,000 people, and then we want this variance to be a proper guess for the whole Hong Kong. But the problem is we only get 1,000, right? The variation of this 1,000 will be less than the 6 million people, right? So you underestimate. So to get the estimate correct, you have to correct that by a small sample -1, get bigger, right? But you can look at the difference between the two is its fraction. When n is big, they're the same, right? Suppose n is 1 million, right? Then this fraction is close to 1. When the sample is very large, suppose big data, doesn't make a difference. Okay? But in Excel later, you will see there are two formulas, variance P, variance S. So that the different population P and S. Okay. But we'll explain why we use this. Okay. It's called sample variance population. Okay. And we often use this one. Okay. And we'll explain why in the second half of the class. So second half of the course. Okay. So when I say variance in the exam or assignment, I will specify it's population or sample. Then you know which one to apply. Okay. But do note that when n is big enough, doesn't make a difference. Okay. So now let's operationalize this data. Okay. As I said, the green box is the thing you should know. So I hope you know how to operationalize this one, as I will actually ask you to do it in your assignment anyway. So it's not how to do it. Of course, you don't have to show me all the calculation. I show this because this is same as you can do Excel. Okay, in Excel easily. So I have data 1, 2, 3, 4, 5. Okay, and I want to calculate the variance. What should I do? I first calculate the mean. Remember, variance what? Variance is the average squared distance from the mean. Okay, so first the mean is 3 because 1 plus 2 plus 3 plus 4 plus 5 divided by 5 is 3. Okay, the second step is calculate the distance from mean. So this column is what? It's just 1 minus 3, negative 2, 2 minus 3, negative 1, 3 minus 3, negative 0, 4 minus 3, 1, 5 minus 3 is 2. Okay, and the next step is you take square for each one. Right? I think if you know Excel, you can easily calculate that one. We'll show you when we work on Excel. I'll tell you you should bring your iPad, your laptop to the class, or at least your class may have that. We'll show you how to do that. Okay. Now what remains is the variance. Okay. Population variance is simply the mean of this number. Remember, it's average square distance of mean. Basically, it's the mean of this number. So just add up divided by 5. 2. But sample is add up divided by n minus 1. So 2.5. Is that clear? Numerator the same. That's the denominator. And I have said when to use which one, right? And if you want, if this is what you have and this is what you care, you should use this one. If this is something that you want, part of the something you want to study, you should use the sample one, right? If you are Alibaba, you are Taobao, you are JD.com, Amazon, all the data. And you only care about your customers, population is the way to go. But if you only collect some data and you want to say the variance of this data to infer what's going on, the variance of the whole thing, then the sample variance is the way to go. Okay, but we'll make clear about this point in our topic 5. Okay, so far now you need to know population divided by n, sample divided by n minus 1, and that's it. That's what you know right now. You don't need to know when to use what. You will know when to use what later. But you have to know the two versions of variance, population one and the sample one. The sample one will be more useful because most of the time we sample. We only get part of what we want to study to infer the whole picture. Okay? But if what you have is what you want to know, then use population. Okay? Remember, we are using this to guess this, and to make the guess, you have to minus 1. Okay? The idea is very similar to doing basketball. Okay? Some of you may be very good at basketball, and if you try to throw a 3-point, then you can just aiming at the circle, just get in directly, right? But when my teacher in high school tell me you shouldn't aim at the circle, right? Instead, right? How you try to aim. I mean, I think many of you are better at basketball than I do. Okay, anyway, I'm not good at sport anyway. So if you want to aim this one, right? You shouldn't go directly, right? Go directly here is very difficult, right? So what you do is like correct them wrong. You should hit here and again rebound, right? So you cannot directly hit it, but you have to hit somewhere else to adjust and go down, right? I think something similar. Okay. Suppose you're a boy. If you're a boy, you change to girl. If you're a boy, you see a beautiful lady there. You want to talk to her. Okay. You want to have her phone number. What are you going to do? Go there. Hey, lady, phone number, please. Doesn't work, right? You talk to her about music, about literature, about film, about nice restaurant, about many nice things before at the end you can ask for telephone number. Same here. You want to estimate the population variance, you can't go directly. You have to go indirectly. Otherwise it doesn't work, right? So remember your flowers or cake or gifts or whatever, right? Same idea. Okay? Sometimes go directly doesn't work, right? Have to go indirectly. Same idea goes on. Is that clear? But so the next one is super simple. Okay, it's just take the square root of the variance. It's called standard deviation. Okay, as the name suggests, it's called standard deviation. There is something called standard, means there's something that we care about deviation, but the standard one. This is the thing that you use most often, right? Standard. So SD as a short form. And basically it's taking square root. The reason why we take square root is very simple. It's measurement unit, right? Because variance is multiplied by self square. So everything is in the wrong unit, right? Variance, if you're measuring the length in terms of cm, right? Then will be cm square for the variance. It's hard to interpret what cm square. Square is a area, right? So we take a square root, then everything will be nice. And later you will learn that y squared is nice is the bell curve, right? And later you will learn that's what we call the empirical rule. Everything is within 3 SD, most likely. Okay, and in bell is everything within 2 SD, right? You learn this standard thing, right? I'm not going to talk about it right now, but later we see. Okay. Last one, okay, which I still have 2 minutes, is the CV. Okay, CV is coefficient variation. Simply very simple. You divide the standard deviation by the mean times 100. Okay, y times 100 is just express this as percentage. Okay, but standard. Okay, and there's a sample one, then use the sample one. Okay, do you want the same to mean? Okay, and why you want to care about that? Because I want to compare across different data sets. I want to say this data is more variation over the other, right? Say suppose I want to say the variance of the exam is more than the midterm exam. Just remark we don't have midterm exam, but in general, variance of the final is more than midterm exam. Why? Because final is from 0 to 100, right? Midterm is usually 0 to 30 or 0 to 50, right? By construction, final has more variance than midterm. But I still want to say something, right, about the variation. So if you divide it by mean, normal of a mean, then you can easily compare, right? If the CV for the final is actually higher than the midterm, then it's the case. It's not affected by the scale or the measurement. Okay, it's normalized by the mean. Okay, that is how you can compare different group. Okay, for example, you may say the variance of income in China is smaller than in US. Okay, but does it mean that inequality is lower? I don't know. It depends on the mean. You have to divide the standard deviation by the mean to do comparison. Okay, so that is useful when you compare across. So my time's up. Just the last example. I mean, it tells you how to do calculation by mean, SD sample, the population 1, CV sample, and the population 1. I hope you go home, can look at it and do the calculation by yourself and see whether you're okay or not. If not, we'll talk about this next time. I see you on Monday. Hope you have a nice typhoon holiday on Friday.